Hey everyone. So if you've ever found yourself staring at a Cisco ACI policy that looks absolutely perfect in the APIC but just refuses to work in the real world, well, you are definitely not alone. Today, we're going to cut through all that confusion. We're going to walk through a clear, step-by-step method to find and squash those frustrating logical bugs and get your applications talking again. You know that feeling, right? It's just maddening. You've spent all this time carefully building your tenants, your app profiles, your contracts. Everything on the screen looks exactly right. But for whatever reason, your endpoints just can't ping each other. It feels like you're chasing a ghost in the fabric. But don't worry, there's a very logical way to track it down. And this quote right here is the key to everything. Solving these ACI issues isn't about guesswork. It's all about systematic verification. We have to close that gap between what we think we told the APIC to do and what the hardware on the leaf switches has actually been programmed to do. That's where we're going to find the truth. To get there, we'll follow this roadmap. First, we'll get into the right mindset. Then, we're going to work our way top-down through the ACI model. We'll start big with tenants and VRFs, then drill into the Layer 2 bridge domains, the Layer 3 subnets, and go all the way down to the applications and endpoints themselves. And to wrap it all up, we'll even decode a couple of the most common fabric faults you're bound to run into. Okay, first things first, our approach is everything. You have to think of ACI policy as a hierarchy, right? You've got objects nested inside other objects. Because of that, a structured top-down process is, without a doubt, the fastest way to find the root cause. We start broad, then get more and more specific with each step. It keeps us from getting lost in the weeds. So this is our game planner, our 4-stage playbook. We always start by verifying the big stuff. The tenant and its VRF, that's the virtual routing and forwarding instance. Once that checks out, we move down to the bridge domain. Then we analyze the subnets inside of it. And finally, we inspect the application profile and the endpoint group, the EPG, which is usually where the problem was first reported. This flow is going to keep you on track. All right, let's get our hands dirty and start at the very highest level of the policy model, the tenant. Or more importantly, how that tenant actually gets built in the fabric as a VRF. Now, this is a super important point, so you'll want to remember this. We sit there and configure a tenant in the APIC GUI all day long, right? But the actual leaf and spine switches, they have no idea what a tenant is. None. All they understand is the VRF, which is written as that combination of the tenant name and the VRF name. This is the real tangible thing that does the routing in the hardware. So what do we check? First off, does the VRF even exist on the leaf switch where your endpoint is plugged in? ACI's smart. It only pushes a VRF down to a leaf if there's an actual EPG using it there. Next, and this is a big one, check its mode. By default, it's enforced, which basically means EPGs are in solitary confinement. They can't talk to anyone else without a contract. If things aren't working, this is a prime suspect. And lastly, see if any vZANI contracts are applied. They're powerful, but they apply rules to the entire VRF and can definitely cause some unexpected headaches. Okay, let's keep moving. Once we've confirmed the VRF is looking good, we drill down one level into the bridge domain. This is the main Layer 2 forwarding world that lives inside that VRF. And here's our checklist for the bridge domain. Now listen, the very first thing on this list, is it associated with the VRF? I'm telling you, this is one of the most common mistakes people make. If you forget to link them, that bridge domain is just an island, totally isolated. After that, you'll want to check the other settings that control how traffic behaves, like how it handles traffic to unknown destinations and whether ART flooding is turned on. ART flooding is absolutely critical for devices to find their gateway. So, Layer 2 is confirmed. Now we shift our focus up to Layer 3. This means we're verifying the subnet configurations inside that bridge domain, and we're checking how they connect to the outside world using what's called an L3 out. When you're looking at a subnet, you've got to ask these key questions. First, is the IP address in the mask correct? I know it sounds basic, but a simple typo can ruin your whole day. More importantly, check the scope. Is this subnet supposed to be advertised to the outside world through that L3 out? Is it marked as shared, which would let other VRFs see it? And if you are using an L3 out, you absolutely have to check its route profile to make sure the right prefixes are actually being advertised. Okay, we've now validated all the network plumbing from the top-level VRF all the way down to the subnet. So the final step in our top-down journey is to inspect the real heart of ACI policy, the application profile, the endpoint groups, and of course the endpoints themselves. For any given server or VM, the first thing you have to do is confirm its policy attachment. Is it correctly tied to a domain? You know, like a VMM domain for your VMware environment, or a physical domain for bare metal servers? Then you can check in the APIC to see exactly where the fabric has learned it. It'll tell you the exact leaf switch, the interface, and the encapsulation VLAN it's using. Now, if you've checked all that and things still aren't working, let me tell you about your new best friend, the operational tab for that EPG. This tab is a goldmine. It doesn't show you what you think you configured, it shows you what the APIC has actually deployed to the hardware. You can see the real interfaces, the real VLANs, and which contracts are actively being used. It's the ground truth. And for the ultimate source of truth, you can log right into the leaf switch CLI. Running a command like this one, show IP interface brief, inside your specific VRF, shows you exactly what the switch hardware is seeing. Right here, we can see that VLAN 20 is up. It has its SVI, that's the gateway IP, with the correct address, and both the interface and the protocol status are up. You can't argue with this. Now, sometimes the APIC IPIC will actually try to tell you what's wrong by raising a fault. But those fault codes can be a little cryptic. So let's break down 2 of the most common faults you'll see when dealing with logical configs. So if you see an invalid VLAN fault pop up, it's a huge clue. It's telling you there's a deployment mismatch. It almost always means one of 2 things is wrong. Either your EPG isn't linked to any domain at all, or it is, but the specific VLAN you're trying to use, VLAN 10 here, was never added to that domain's VLAN pool. Just make those 2 things match and the fault will clear. And it's a similar story for the invalid path fault. This one is all about the physical or virtual paths. It means your EPG is trying to deploy on a switch port that hasn't been given permission through the domain configuration. The fix is to go check your access policies and make sure the right interfaces are associated with that domain. So there you have it, a structured, top-down methodology for tackling logical constructs in ACI. By starting at the VRF and methodically working your way down to the EPG, you can pinpoint issues so much faster. It really transforms troubleshooting from a frustrating guessing game into a logical, repeatable process. So the next time a connectivity ticket lands on your desk, you'll know exactly where to start.